Now, there's two ways to do this problem. It is an exponential function. There is a formula for the derivative of an exponential function. Now, if you don't know the formula, there's another way around it. Okay, and it's really easy if you guys understand logarithms. Okay, so if you know logs, this is handy. Now, if you know the formula, you can use the formula, but I'm going to do it with natural log. If you know the formula, just go to the formula and look at it. There is a function inside of a function here, so you're going to have to do the same thing, kind of like what we did with the inverse sine. But here, let me show you guys how to solve this using natural logs. So, oops. Now I need to remember, after I'm done, I got to plug in the 2. So I first got to find the derivative, and then I'm going to plug in the 2. So, if I wanted to find the derivative of this, what you can do is you can natural log both sides. You might be thinking, why would I do that? You would want to do that because then you could take this power and you can bring them down. Because whenever you have a power inside of a log, you can do that. It's a cool rule that you guys learned in Algebra 2. And so now I have 1 minus x times natural log of 2. And on this side, I have just natural log of y. So I just manipulated it a little bit. And now I'm going to take the derivative with respect to x. When I take the derivative with respect to x to the first guy, it's implicit differentiation. So first, you take the derivative of the natural log of y, which is 1 over y. And then you have to multiply this by the derivative of the inside function, which is y. So we're just going to write dy dx, or you guys can write y prime. Doesn't matter which one you write. They're both the same to me for now. On the other side, we have this natural log of 2 right here. And you might be freaking out because of him, but don't. The reason why is because natural log of 2 has no x in him. And so when it comes to finding the derivative, he is like a scalar. He is like a coefficient. He doesn't matter. Okay, so what you could do is ignore him for a little bit and just take the derivative of that. What is the derivative of 1 minus x? Negative 1. So now, after you take the derivative, then you multiply your result back to the constant or scalar, whatever you want to call him. And so we actually have negative 1 times natural log of 2. So this is what we have. We have 1 over y times dy dx, which is what we're looking for. We're looking for dy dx, because that's the derivative, equals, and on this side we have negative natural log of 2. Is dy dx alone? No, so we don't know what the derivative is yet. So let's get him alone. What would I do to get him alone? Multiply by y. Or if you said divide by 1 over y, that's the same thing. Good job. So I'm going to multiply this side by y. And what do I get when I do that? What is y, by the way? Do you guys know what y is? These will cancel out. I'm left with dy dx over here. And on this side, I know what y equals. Y equals 2 raised to the 1 minus x. It says right here. So then I write, I guess you can, you just write it like this. Natural log of 2, negative natural log of 2 times 2, 1 to the negative x. Now, plug in the 2. Right? We got to plug in the 2. So now I'm plugging in the 2. I have negative natural log of 2 times 2 raised to the 1 minus 2, which is negative 1. So that's a 1/2, right? This is 1/2 times negative natural log of 2. There's like a negative 1 in front of the natural log, so we have negative 1/2 natural log of 2. That's one way you can write it. Another way you can write this is you can put the natural log on top. So it'll be natural log of 2 divided by 2. Do you guys see that answer anywhere? There he is. I forgot to mention I didn't talk about translating this question, because some of you guys might have just read this question and you were confused. And all of a sudden I just started solving it. Sorry. It says, which of the following gives the slope of the tangent line? Okay, now if you wanted to find a slope of a tangent line, that is finding the slope at a point. If you're finding the slope at a point, you need to find the derivative, and then you need to plug in that point. And when I say plug in that point, I don't mean an x and a y, I mean just the x. Well, for this one, because we're not doing differential equations yet. Okay, so this is really essentially looking for, like if this was f of x, this is looking for f prime of 2. This is your whole goal right here. This is what you're trying to find. So you have to find a derivative, then you have to plug in 2. All right, it's a weird way to ask it, but this is the way it asks it. Another way it could ask it could say this. What is dy over dx at x equals 2? That's another way to ask it. So there's different ways to ask the same question. And I hope that you guys realize a lot of calculus is repeating itself over and over and over. It's taking the same concept, a derivative, and throwing it into different scenarios and wording things a little different to kind of confuse you. And then actually the goal is not to confuse you. The goal is to see if you can critically think about the problem. So that problem's done.